All right, guys, how we doing? All right, I'm gonna give this a shot. This document camera is being beyond annoying, but all right. So I'm gonna break this week's lessons into 3 videos. As always, you know, go your own pace and make it work for you. So here goes. The aim for this series of lessons is how do we determine angle measures of a circle using chords, tangents, and this new word, secants. All right, it looks like secant. Don't say that. You sound stupid. All right, so secant. So the first thing I'm going to do just to get that out in the open and make sure that you're aware of it is to define that. All right, so a secant is, you know what a tangent is from last week. All right, this is a tangent where there'll be a line or a line segment or array that intercepts the circle in exactly one location, right? But a secant is going to go through the circle. All right, so this is a secant where it's going to hit the circle in 2 locations. I didn't even think about it. You can have a line that doesn't intersect the circle at all. You can have a line that just kisses it like a tangent, or you can have a line that goes through it at some point and therefore has 2 points of intersection. To me, this looks like it's not. There we go. That looks like a little better clarity for you guys. I like did it automatically last time, and now it's not. But whatever. All right, so that's that. So the first thing we're going to do is actually not going to have anything to do with secants. So here's your first theorem, and I'm going to do this the application of this I'm going to do 2 ways. So just stay with me. So the theorem states that the angle formed by 2 chords intersecting. So 2 intersecting chords. So okay, I got 2 intersecting chords here, and I got 2 intersecting chords here. So okay, that makes sense. So the angle formed by those 2 intersecting chords within a circle is equal to 1/2 the sum, half the sum, that's an important phrase, of the measures of the arcs intercepted by the angle and its vertical angle. Okay, so there's like a lot of words there. So, and this is kind of a wordy option here. So I want to look at this, and I'm going to just pick, I'll pick this angle right here. All right? So, first of all, you should know that if this angle, whatever this angle is, you know this angle is going to be the exact same thing, right? Vertical angles. So, the relationship is between the intercepted arcs. So, from this angle, we're looking at that arc. And for this angle, we're looking at this arc. All right? So, these 2 angles, which are the same, are going to have a relationship that you're going to figure out, a calculation that you're going to make based on these 2 arcs. Now, half the sum of 2 things. Half, just like dividing by 2, the sum of 2 things. You add 2 things, you divide by 2. All right, we would go through this in class, but we make sure that you remember that that's just another way of saying average of the arcs. All right, so what you're really doing here, all right, is average of the arcs. All right, now, so you're going to look at these 2 arcs. Now, you're going to have to know what they are, of course. All right, so in this case, I'm going to say that, this arc up here is 40 degrees. All right. And this arc down here, I'll tell you, is 120 degrees. All right. Now, before we get into too much with that, I want to stay a little bit in the theoretical for a minute or two. So, if we're looking at this, and we look at this blue dot angle, so I'm going to call that the measure of angle AEC. Now, AEC is going to be the same as BED because of vertical angles. But what I want you to know here is that that's going to equal 1/2 the sum of these 2 arcs. So arc AC plus arc DB. So you add up these 2 arcs, multiply by half or divide by 2, whichever way you want to kind of make it work for you. Obviously, same thing. All right? And you'll calculate that angle. All right? Now, I just happen to pick these 2 angles. I could have done these 2 angles, AED and CEB, and then it would have been these 2 arcs added up and divided by 2. So you're either averaging these 2 arcs to get these angles, or averaging these 2 arcs to get these angles. All right, in this case, you know what we did, so that would mean 1/2 of 40 plus 120. 40 plus 120 is 160. Half of that is 80. So we're at 80 degrees there. So the measure of angle AEC is 80 degrees. Okay, well, if this is 80 degrees, this is 80 degrees. And if these are 80, then you know supplement right next to them, these would be 100. Now, I don't know what these arcs are here, but what I can tell you is that if their average is 100, you got to add them up and divide by 2. So at least you know they add up to 200 then. That's a little bit of a higher level thing. So what you need to know in this is when you have two intersecting chords, which kind of make a plus sign, sort of, right? I mean, forcing it a little, but you're adding them up and dividing by 2. Add up the two intercepted arcs and divide by 2. Now keep in mind, right? This is 80 here, right? So wait, why was this 80 but this not 80? Well, it's not a central angle like we talked about 2 weeks ago, right? Its vertex is not O, right? This is just intersecting within the arc somewhere. All right, so that's the first way of applying this. The second way of applying this, I don't know if you'll think it's tricky or not. It shouldn't be, all right? But if we're looking at that, now I'm going to tell you this angle right here, all right? I'm sorry, excuse me, this arc is 30 degrees. And on this one, I'm going to tell you the angle, all right? So if this is 30 and this is 65, and I ask you, hey, figure out the arc. All right, first you got to make sure you're dealing with all the right pieces. All right, these angles, right, are going to have these two arcs averaged. So in other words, there's two ways for you to look at this. All right, algebraic way, and in my opinion, number sense / easier way. All right, you could say, all right, well, hold on, these two arcs still have to average 65. So you can say 30 plus x divided by 2, or 1/2 of it, right, has to equal 65. Take it algebraic, multiply both by 2, subtract 30, you're done. Or there's another easier way of doing it, which is you say, all right, you know if this is 65, this is 65. So to get from 30 to 65, what do? Like how do you, I think of it as like a translation thing. All right, oh, well you'd have to add 35. And then if you do it again, add 35. 65 plus 35 is 100. And that's it. All right, now this would give you 100 as well. But in my opinion, since you know 65 is the middle, right? It's kind of like the median value, right? Between 30 and some other number. Because when you're averaging two numbers, right, that average has to be dead smack in the middle of those two. So if it's 35 up from 30 to get to 65, it's another 35 up to get to the other one. Otherwise, 65 wouldn't average it. And you could always quick calculate, oh, 30 and 100 is 130, divided by 2, 65, it checks, you're good. All right, so either of these approaches will work. All right, so that's the first one. The next 3, I'm going to split into 2 different videos to show you 2 different approaches. All right, so here goes.